Hello! In this lecture we will be discussing about divisibility and we will try and verify whether it is an equivalence relation or not. For that, first we'll have to understand what a relation is, then we'll be looking up the different types of relations, and then we'll be able to understand if these relations exist, then it is going to be an equivalence relation. Further, for divisibility we will check it using a sum. So let us try and understand all of this in detail. First, starting off with what a relation is. Now, when we talk about a relation, we actually mean to say that we are interested in getting a subset of the Cartesian product of two sets. For that matter, let us now consider that we have a set A and the elements of the set A are like A, B, C, and let us consider another set B which say has some elements like 10, 20, right? Now, if we are to find out the Cartesian product, which is A cross B, then what we'll do is we will make some ordered pairs, picking up the first element from the first set and the second element from the second set. As such, A comma 10 and A comma 20 will be the first two ordered pairs, after which you will have B comma 10 and then B comma 20 to be the next two ordered pairs, and finally we will have C comma 10 and C comma 20 to be the third group of ordered pairs. And now these are the ordered pairs and they all represent the Cartesian product. Now, if we take a subset of this Cartesian product, then it will be said to be a relation. For that matter, if we are interested in what's happening with 20, then this can say be represented to be a relation which is capital R, and here then we will write it to be A comma 20 to be the first ordered pair. Then we have B comma 20 which will become the second ordered pair, and then we'll have C comma 20 which will become the third ordered pair, and all of these, as they're concerning with 20, can be considered to be those ordered pairs which are forming this relation. Right now, as you saw here, we talked about this relation to be a subset of the Cartesian product. Remember, when we talk about the subset, it means that either all the elements or some elements which are lesser than the set of whose subset you're trying to make, but the elements should not be out of that set whose subset we are trying to make, right? So here, as such, a relation has been formed from the Cartesian product of these two sets A and B. So this is how we define a relation. Now, when we talk about a relation, there are primarily three types of relation that at the moment we are going to consider. The first is we talk about a reflexive relation. Now, if we talk about a reflexive relation, then we talk about an element to be having the relation with its own self, or in other words, we can say that we require A comma A to be the ordered pair of that relation. Now, if we want another relation to be having this characteristic that is symmetric, then it should be exhibiting this property, that is, if we have an ordered pair which is A comma B, right, already, then we check for B comma A, which is the other ordered pair, and as you can see that this is just an inverse relation. That means the second element has become the first element and the first element has become the second element, right? So these are the first two types of relations. Now, after this we have the next one, which is the transitive relation. So when we talk about the transitive relation, it is this, that we should be having the first two. That means if we have an ordered pair which is A comma B, and we also have another ordered pair which is B comma C, and then if we talk about trying to get the ordered pair A comma C, that is the first element with the third element, then we say that this relation is a transitive relation. So this is how we understand the relation of the three different types, and if the relation is to be such that it is of all of these three types, and then you will say that it is equivalence, right? So for a relation to be an equivalence relation, all of these three should exist simultaneously. If there is one which is not existing, then the relation might be some of these two different type of relations, right? But it will not be an equivalence relation. Okay, now children, having understood all of this theory, I will now quickly move on to the sum. Okay, there's somebody in the class who wants a second explanation, so I'll help you with the second explanation. So make sure you don't pick up your pen at this time, any writing material, right? Make sure you're seated in a table and chair and straight with your spine straight, right? Don't pick up a pen, right? Don't scratch and scribble and put your hands through your hair. That disturbs, right? Sit motionless and focus exactly where I am. For that matter, you also require to sit in a place where you have no people moving around and disturbing you, and no electronic gadget like a TV, mobile, a laptop, etc. there to disturb you, right? You should switch it off or you should put it away for the time being till the time the studies are happening. Okay, here we are studying divisibility as an equivalence relation. So what do we do here is we have a set A, which is A comma B comma C, and we have another set which is 10 comma 20, and we try to find out the Cartesian product of both of these sets, which will have now ordered pairs where the first elements will become the first elements of the ordered pair and the second elements will become the second elements of the ordered pairs. Now after we have this Cartesian product, then from this we choose a subset with a specific characteristic, and that then becomes a relation. So here we chose a relation which was a subset of this given Cartesian product to be such that it is related with 20. As such, this and this were the ordered pairs which were chosen, and it now gives this relation capital R. Now another thing I told you here is that if you talk about a subset, it is such a set which has either the same elements all over or some elements less than the original set. Although all the elements or the ordered pairs, they should be chosen from the main set of whose subset you're trying to make. Okay, now children, after this we looked up the different types of relation. So the first being a reflexive relation, where we talked about an element having a relation with its own self. If that is true, then we say that it is a reflexive relation. For that matter, if you say is a friend of, so you can be having a friend whose name is Avichal and say your name is Parth. So Parth is the friend of okay, when you talk about a relation with its own self, then you'll be talking about the element with its own self. So if you talk about Avichal, so Avichal obviously is a friend of his own self, and that's why he does things which says that he is concerned about his own self, right? So that's why Avichal comma Avichal is possible, or in other words, the relation is a friend of is possible with his own self, and as such you will say that this is reflexive. Now if you talk about a relation to be a symmetric relation, then the relation should be an inverse relation. That means if you get an ordered pair A comma B, then you will also get an ordered pair B comma A, right? So this shows that the relation is a symmetric relation, and in fact it points on a inverse relation. Now when we talk about a transitive relation, we require to remember that the first two should exist. For that matter, in the above symmetric relation, you should remember that if the first condition, that is A comma B, exists, then we go and check for the second condition. Now here there are two conditions to check. First is if A comma B can form an ordered pair, B comma C can form an ordered pair by using some relation, then A comma C will also have the relation, and then you'll be able to say that this relation is a transitive relation, right? And if there be a relation which has all of these three, that is a reflexive relation, a symmetric relation, and a transitive relation, then you will say that it is an equivalence relation. Is everybody clear? For sure, Parth? Good. Okay, now children, after this I have a sum for you people, and I'll give you people a little time for trial. Obviously that is not going to be much, right? But when you're to try it out at home, make sure that you pause the lecture for a longer duration of time, something like 4-5 minutes. Give it a good try, give it your best. Even if you think that you will not be able to do the sum, just pick up your pen and give it a try, right? You will find that there'll be times when you'll be able to crack the best of the sums which even the best of the children falter to solve, right? So when you start believing in yourself, then your subconscious will provide you a lot of strength so that you can do miracles, right? So before I get started with the sum, first I was to give you people a little bit of time for trial, like I said. So I'm going to give you here at this time just 10 seconds. Remember children, you can have an access to a live class. You can have an access to different PDFs for this chapter or for any chapter, or you can even have self-paced courses for any chapter. All of these are available, all of my resources. There is test series to which you can subscribe, right? For all of this you should just be filling up a form which is there in the profile, right, or in the description of my channel, and just fill in a little bit of particulars which are required to be able to understand what your needs are. Then you will find me coming back to you, taking you people to a live webinar where we'll have a chat and we'll try and understand what your needs are and how I can customize your needs so that you tomorrow can get to that magical figure which is 100, right? Okay, so I'll be waiting for you people, and I'll want you people to fill up the form and get to me as soon as possible so that I can make you join my community where we actually move from education to employment. Okay, so now children, here we are talking about verifying whether the relation a minus 2b on the real numbers is divisible by 7 is an equivalence relation or not. So what do we do first is we will now first be talking about this relation which has been given, that is a minus 2b, and we are going to consider some numbers for a and b. So our first task is to take an assumption. So let us assume that as you've got to show it to be a divisible by 7, so we will consider say a to be equal to 7, and let us consider b to be equal to say minus 14, and let us consider c to be equal to 21, right? So we have considered these three numbers randomly, but one thing has been ensured, that they are all to be already multiples of 7. So further here, next, the first thing that you're going to do is you'll be talking about here the symmetric relation. So when you talk about the symmetric relation, children, I'm sorry, not the symmetric but the reflexive relation, which comes first. So in reflexive relation, you'll be talking about checking for the relation with just one element, right? And in it you should get to a comma a, right? So here when we talk about the element 7, right, we've got to subtract from 7 2 times of 7, and that actually gives us 7 minus 14, and that will further become equal to minus 7, and you know that this is divisible, right, by 7. It can be a negative number. It obviously on being cancelled will come to a negative integer. Doesn't matter, even then you are left out with no remainder, and that is the basic premise in trying to find a number, whether it is divisible by another number, right? So this, children, is the reflexive relation, where we talk about trying to find out whether the element has a relation with its own self or not. And as this has come out to be true, and thus you can say that if you talk about the ordered pair, then you will have the ordered pair to be say some a comma a, which actually here is what? Here it is the first element 7, with which we have checked, right? And here this is represented by these three lines, mean represented by 7 comma 7, right? And thus you can say that therefore relation is reflexive. Okay, after we have the relation to be reflexive, our next task is to talk about it to be symmetric, right? So by the definition of a symmetric relation, we know that we have to check for an inverse relation, right? So when we talk about a symmetric relation, we will want to have a comma b existing, and then we should be able to have b comma a. So we will say that if a comma b, then we should get to b comma a, right? Now children, in order to do this, first we're going to do is we have taken our a to be equal to 7, remember, and we have our b to be equal to minus 14, right? So if we talk about the ordered pair a comma b, right, so we now have a minus 2b, remember, which has to be checked, right? So when we talk about a minus 2b, then it is going to become equal to 7, from which you're going to subtract 2 times of minus 14, right? That is b. So this then is going to become equal to 7, from which you'll be subtracting and also a negative number. So as such, minus minus will become equal to plus. Now 14 to the is 28, so 7 plus 28 is what you're going to do, and that thus is going to become equal to 35, right? And here you can say that this is divisible, right, by 7, right? And thus here you can say that therefore relation is symmetric. Oh wait, we also have to check it out for b comma a, right? This is just one way. Okay, now we have to do the main thing, which is part of the proof. That is, now we go ahead with the second part, and now we have our a. You can at least say this, that we have therefore a comma b, which here in accordance with this condition is 7 comma minus 14, which is already existing, right? So now we talk about b comma a. For that we again have our a, which is 7, and we have our b, which is equal to minus 14, right? Now what we've got to check is we should be able to check whether b minus 2 times of a also gives us a number which is divisible by 7. So for that we keep the value of b, which is minus 14, and from that we subtract 2 times of 7, which is the value of a, and as such here we will get minus 14 and minus 14, right? And that is then going to become equal to minus 28, right? And you know that this is divisible by 7, right? As although it is negative, so on cancelling you will get a negative integer, that is minus 4, but even then you can say that it is divisible by 7, right? Okay, and now thus you can say that therefore if you have 7 comma minus 14, then you also have minus 14 comma 7, and therefore you can say that here you're talking about a symmetric relation, right? Okay, now after this children we'll be talking about the next one, that is for transitive relation, and this is the one in which maximum number of children falter. You have to remember that if we are to talk about the transitive relation, then 3 things are to be there, out of which the first 2 things should already be existing. Then you go and check for the third one. That is, you will say that if we have a comma b, which is an ordered pair, and then we also have b comma c, which is another ordered pair, and then we go and check for a comma c, which is the ordered pair. If had, then you can say that the relation is transitive, right? Otherwise not. Okay, so here children what we're going to do is we will now pick up the value that we've already taken for a, b and c. We have the value of a to be 7, remember, we have the value of b to be equal to minus 14, remember, and the value of c is equal to 21 if I remember correctly. So let me quickly go and check. We have the value of c to be how much? The value of c is indeed 21, right? So first for a comma b we will have to check for a, which is 7, from which has to be subtracted 2b, right? That is 2 times of minus 14, and earlier just now we've already seen that this is true, so we have 7 plus, as minus minus will become equal to plus. 14 into 2 is 28, and 28 and 7 is 35, so obviously this is divisible by 7, right? So you can say is divisible by 7. Now we talk about the next one, which is b comma c. And for b comma c, what do we have is we have a minus 2b, that is a is minus 14 minus 2 times of 21, which is c. So here we get to see that we have minus 14 and minus 42, right? 2 and 4 is 6, and 4 and 1 is 5, so that becomes equal to minus 56, and here too you can say that this is divisible by 7. Now finally we have got to check for the third one, right? And for the third one we have to check for a comma c, right? These first two had to exist, right? And now if the third one also exists, then we will say that it is transitive. So here we are going to check for a minus 2b. So as a is how much? A is 7, right? And here we have the value of c to be equal to 21, right? So as such, a minus 2b will be the same as 7 minus 2 times of 21, right? And that thus gives us 7 minus 42, right? 7 and 5 is 12, right? And then further we have 1 and 3 is 4, so we have 35, that too with a minus sign. Now this is divisible by how much? By 7, right? And therefore you can say that this relation is transitive, right? So you can say that this relation is transitive. So as this relation is transitive, our next task is to talk about it to be equivalence or not. So we will say that since R is reflexive, remember first, right? Then it is also symmetric, right? And it is also transitive, remember. Therefore the relation R is equivalence relation, right? Okay, so children, I'll just quickly discuss this all over. This was a long sum, and I'm sure for this you must have intrigued a lot, but even then, now I think solution is clear, right? But even then I'll just discuss again so that if there are few doubts, they're all clear. So in the question, children, you've been given to verify whether the relation a minus 2b on real numbers is divisible by 7 is an equivalence relation or not. For that, what you do is we take here 3 numbers a, b and c to be able to understand this case in a better way, because when they are numbers, they're getting subtracted, then you will understand more, right? I can do it with variables, but it won't be understood as well as when you do it with numbers, because numbers obviously get calculated, come to a lesser number, which proves as to what you're doing, right? So here we've considered a to be 7, b to be minus 14 and c to be 21, right? And the logic is that as it is to be shown to be divisible by 7, so if we take numbers which are already divisible by 7, then on subtraction also the difference will come to be a multiple of 7, right? Now you can try it out in certain cases with other numbers, but in this function a minus 2b, if you talk about other numbers, this is not existing, right? Okay, so the first thing that we try and check is for the reflexive relation, where we talk about 7 minus 7 times of 2, because it is a minus 2b that we've got to check for the relation, right? So next now we talk about 7 minus 14, which becomes equal to minus 7, and this is divisible by 7, remember. Now as we have a comma a, and thus we can say that this being represented by 7 comma 7, and as such we have the relation to be reflexive. Next, now we talk about symmetric relation, where first we should be having a comma b as an ordered pair, and then we check for b comma a or the inverse relation. So here we have our a, which is 7, and we have our b, which is minus 14. So if we talk about writing a comma b, that is what also we were to write and find out, right, whether that is coming to be true or not. Only then we can go for the inverse relation. So a comma b is what? A comma b is 7 minus 2 times of minus 14, as the value of b is minus 14, right? So you can check it out from here. You have the value of b to be minus 14. Now 7 minus minus will become equal to plus, and you will get 28 here. So 7 plus 28 will become equal to 35. Now this is divisible by 7. So this is a comma b, which has come into existence. Now we go for b comma a. For that, a is 7, right, and b is minus 14, right? So if we talk about this here, we get to see that if we talk about b comma a, we will have to consider a as b, right? So we'll have minus 14, and from that is going to be subtracted minus 2 times of the value of a, right, which now has become the second value, that is like b. So as such, this becomes equal to minus 14 and minus 14, which becomes equal to minus 28. I'm sure a little bit of ambiguity is still left. I said that earlier we did a comma b. Now we've got to try and check for b comma a. As such, whatever will be the value of b will now become the value of a, and what the value of a is going to become the value of b, right? Because we're trying to check for b comma a. So actually we've got to check for what? We actually have to check for b minus 2a, and that is why we've done this, right? So b minus 2a is obviously minus 14 minus 2 times of 7, right, for the inverse relation b comma a, and that comes to minus 28, and this is also divisible by 7. As such, this relation is even reflexive. Now we've got to talk about the third case, where we talk about the transitive case, where if we have a comma b and b comma c to be the ordered pairs, then if we are also able to get to a comma c, then we will say that it is transitive. Now here, children, first what we do is we talk about a, b and c as we've already assumed. Then we calculate a comma b, right, which on calculating by keeping the value of a to be 7 and b to be minus 14 comes out to be 35, which is divisible by 7. Then we call in b comma c, where b is minus 14 and c is 21, so it becomes equal to minus 14 minus 2 times of 21, right? So that becomes equal to minus 42 minus 14, and that becomes thus minus 56, which is also divisible by 7. Next, we talk about a comma c. So that is a taken to be 7 and c taken to be 21, right? We will try and check for a minus 2c. That is 7 minus 2 times of c is 21, right? So remember here also we did the same. We took the first number minus 14, which was the value of b, and we took the second value for the second value of c, that is 21. Now here we solve it out. So this comes to 7 minus 42, which will become equal to minus 35. This is also divisible by 7. As such, this relation is even transitive, right? Okay, when this relation is transitive, then you can now say that this relation is an equivalence relation, because all the three which required it to be an equivalence relation have been solved, right? And thus this sum stands to be 1, which is that divisibility is an operation which is an equivalence relation on the set of real numbers, right? So children, understood this, like this, want more of it? So obviously you should click on the subscribe button, so that when some such sort of lectures come to you, right, you get to see. And moreover, when they come to you, if you want to be notified, make sure that you also click on the bell icon. If you've liked it, I'm sure your friends will also like it and will also be helped. So do share it in your community, and you will have a lot of repute to be one who is magnanimous, that is, who is merciful, and obviously then you will enjoy a lot of goodies in your community. People are going to respect you, people will serve you good treats, they will take you to their homes and this is only going to happen when you start sharing my lectures, okay, because they are indeed good, right? I can tell you that. Okay, the second thing is this, that this is a recorded lecture, right? If you want to come live into my classes, what you're going to do is, there is a form link which is there in the description, or there is a form link which is also there in the description of this lecture, right? Make sure you click on that link and you come to me, register your interest that, sir, I want to study live, because then whatever topic you want to study, I'll be able to teach you that, making you sit just in front of me, obviously online, and then you'll be benefited a lot, because there are a lot of the things which go off which you're not able to do because you're lazy, right? So if you're able to get the proper amount of academics at a proper time, then you can even pursue your sporting activities, right, which you're normally missing on because you've got to go to the coaching, right? So do tell me what your problem is, and you'll get me coming back to you and answering all your problems and making you to get a perfect 100. So bye children, have a nice time, and do practice the sum ones just now.